Welcome back to Making AI Make Sense. Today we're covering something that seems almost too simple to be true. There's a prompting technique that can dramatically improve AI performance, and it's just asking it to show its work. That's it. A few extra words in your prompt. Now, here's what makes this interesting. AI doesn't actually think or reason. So, why would asking it to show its work make any difference at all? The answer is going to connect everything we've learned about pattern completion and reveal how these systems actually process complex problems. Let's figure this out. I want you to picture two scenarios. In the first one, you're working with AI in something complicated, maybe a business analysis, maybe a math problem, doesn't matter. You ask your question, AI spits out an answer, and it's wrong, or incomplete, or just feels off somehow. Second scenario, same question, but this time you add one phrase. Show your work step by step. Suddenly the response is better, more accurate, more reliable. The AI actually works through the logic instead of jumping to a conclusion. This isn't a small difference. For certain types of problems, this technique can be the difference between useless output and genuinely helpful analysis. And the fascinating part, the AI is still doing the exact same thing under the hood, pattern completion. We're just structuring that process differently. So, what's actually happening here? Why does this work? Let's establish the puzzle clearly. We know from video 1 that AI is pattern completion. It's predicting the next most likely token based on patterns it learned during training. There's no consciousness happening, no actual thinking. It's sophisticated autocomplete, not a mind. So here's the paradox. If the AI isn't reasoning, if it's just matching patterns, why would the way we ask the question change the quality of the answer? Pattern matching is pattern matching, right? Wrong. And understanding why it's wrong is going to give you a much deeper understanding of how to use AI effectively. Because it turns out that how you structure the pattern completion process matters enormously. The AI is still just predicting tokens, but we can influence which patterns it activates by changing how we ask. This is powerful once you understand the mechanism. Before we go further, I need to clarify what this video isn't about. We're not talking about how to check if AI got the right answer after the fact. We're not discussing verification or error catching as a post-processing step. What we're exploring is why, mechanistically, at the token level, breaking problems into steps produces better initial results. This is about understanding the technique well enough to know when to use it and when not to bother. Think of this as understanding the tool, not just learning how to use it. Once you understand why it works, you'll make better decisions about when it's worth the extra tokens and when it's overkill. Here's an analogy that'll help frame this. Two students, same math test, same problem. One student reads the question and immediately writes down their final answer. The other one shows every step of their work, writes out each piece of the process as they go. Which student is more likely to get it right? Obviously, the one showing their work. We all know this intuitively from school. Teachers always told us to show our work, and there's a reason for that. But here's the thing, the reason it helps students is completely different from why it helps AI. Humans benefit from externalizing steps because of our working memory limitations and cognitive biases. AI doesn't have those limitations, so the mechanism must be something else entirely. Think about why showing work helps a human student. The direct answer student is holding everything in their head. They're doing mental math, keeping track of multiple pieces simultaneously, and hoping they don't lose track of something along the way. It's fast if they're good at it, but error prone because our brains can only juggle so many things at once. The show your work student has offloaded cognitive burden onto paper. Each written step is a checkpoint. They can look back and verify their logic. If something's wrong, they can trace back to find where the errors crept in. Now, AI doesn't have working memory limitations like we do. It's not juggling information in its head and occasionally dropping something. So, why does showing work help? Different mechanism entirely. We need to think about this at the token level, not at the cognitive level. For humans, the benefit is about managing cognitive load and catching our own mistakes. We write steps down so we don't forget where we are. We externalize so we can spot errors. AI doesn't forget. It doesn't get confused along the same way we do. It's not checking its work as it goes. So what's happening? The key is to stop thinking about this through the lens of human cognition. Stop thinking about understanding or checking your work or staying organized. Those are human problems. AI has a completely different problem. It needs to predict the next token with only the context that's been given so far. And here's the insight. When you ask for steps, you're giving the AI more context to work with at each stage. Each intermediate step becomes new context that wasn't there before. Okay, here's what's actually happening mechanistically. When you ask AI to show its work, you're triggering a different pattern completion process. Instead of jumping straight to the answer, the AI generates intermediate steps. And here's the crucial part. Each of those steps becomes part of the context for what comes next. The AI isn't working through the problem the way a human would. It's generating token after token, and each token provides additional context that influences what token gets predicted next. Think of it like building scaffolding. Without chain of thought, the AI is trying to jump directly from question answer in one leap. With chain of thought, it's building intermediate platforms that it can stand on to make the next leap. Each step creates a better launching point for the next prediction. This is still pure pattern completion, but by structuring it into steps, each giving the pattern matching engine more information to work with. More context means better pattern activation. Let's connect this back to the foundation we built in video one. Remember, AI predicts the next token based on patterns. When you give it minimal context, it has limited information to guide that prediction. Lots of possible patterns can match. But when you structure the output into steps, something changes. After the AI generates step one, that step is now in the context window. When it goes to predict step two, it's not just working from your original question anymore. It's working from your question plus step one that it just generated. This is how autocomplete on your phone gets better as you type more words. With only I'm going, autocomplete has thousands of options. With I'm going to the grocery store to buy, it narrows down dramatically. Same principle. More tokens in the context equals more specific pattern matching for what comes next. The AI isn't reasoning. It's just that each step you make it generate becomes new context that constrains the pattern space for the next step. You're forcing it to build context progressively rather than trying to match patterns with minimal information. Let me show you this in action with something concrete. If you ask AI, what's 15% of 847, without any additional prompting, it tries to jump straight to the answer. It activates patterns related to percentage calculations and multiplication, makes its best prediction, and outputs a number. Sometimes it gets it right, sometimes it doesn't. And the problem is, if it gets it wrong, the error is baked into that single token prediction. There's no opportunity for course correction because it jumps straight to the final answer. Now watch what happens when you add show your work step by step. The AI can't jump to the answer anymore. It has to generate intermediate steps first. So it outputs convert 15% to decimal 0.15. That's now in the context. Then it generates multiply 847 times 0.15. That's now also in the context. Then it breaks down that further. Each of these steps activates more specific patterns. The pattern for break this multiplication into parts is different from the pattern for solve this percentage problem in one shot. By forcing intermediate steps, you're guiding the AI through a series of narrower, more specific pattern activations instead of one broad error-prone jump. Here's a classic logic puzzle that shows this even more clearly. 5 machines take 5 minutes to make 5 widgets. How long for 100 machines to make 100 widgets? The intuitive answer is 100 minutes. The AI trained on human text has seen that intuitive wrong answer pattern many times. So without chain of thought, it often activates that proportional scaling pattern and confidently says 100 minutes. But when you force it to show steps, something different happens. It can't jump to the proportional scaling pattern. It has to first generate something about the rate of individual machines. That forces it to activate unit rate patterns instead. Once each machine makes one widget in 5 minutes is in the context, the path to the correct answer becomes much clearer. The AI didn't realize its mistake or think more carefully. It just activated different patterns because of how the problem was structured. Chain of thought changes which patterns get activated by building context step by step. So, when does this actually matter? When should you bother adding those extra words to your prompt? The pattern is pretty clear. Anything with multiple steps where each step depends on the previous one. Math, obviously, logic puzzles, but also planning. Breaking down a project into phases where later phases build on earlier ones. Debugging code where you need to trace through execution step by step. Comparing options where you need to systematically evaluate criteria before making a judgment. What all these have in common is that jumping straight to the answer is likely to activate the wrong patterns. You need the intermediate context to guide the AI toward the right pattern space. The task structure benefits from scaffolding. And here's a key insight. This is the most valuable when the problem is complex enough that there are many possible pattern matches. Simple problems don't benefit as much because there's usually one obvious pattern that dominates. Complex problems have many competing patterns, and chain of thought helps navigate toward the right one. Now let's talk about when this technique is a waste of tokens. Simple fact retrieval. What's the capital of France? Doesn't benefit from steps. There's nothing to break down. It's direct pattern matching from question to answer, and adding steps just makes the AI do unnecessary work. Creative writing is interesting. You might think showing your work would help structure a story, but it actually kills the flow. Good creative writing comes from letting patterns flow naturally, not from mechanically breaking things into steps. It's like asking a jazz musician to explain each note before they play it. You lose the spontaneity that makes it work. And here's a big one that connects back to video 3 on hallucinations. Chain of thought doesn't make facts more true. The AI can confidently show you step by step reasoning that arrives at a completely hallucinated fact. The reasoning might look logical, but if the patterns it's activating are based on incorrect associations from training, showing the steps just makes the hallucination more convincing. So this helps with process, not with truth, and that's a critical distinction. Okay, big misconception to address. When people see AI showing its work step by step, they often think, "Oh, it's actually reasoning. It's thinking through the problem like I would." No, still pattern completion, just structured pattern completion. What's happening is that each step generates more tokens, and more tokens means more context, and more context means better pattern matching. But there's no understanding, no consciousness, no actual reasoning process happening. Think of it like this. When your phone's autocomplete gets better suggestions as you type more words, you don't say it's understanding you better. It's just that more context means the pattern matching algorithm has more information to work with. Same thing here. Chain of thought gives the pattern matching engine more information at each step. That's it. It looks like reasoning because the output has a logical structure. But that structure emerges from progressive pattern matching, not from actual thought. Second major misconception. If the AI shows its work, it can't hallucinate. The reasoning process will catch errors and self correct. Actually, not. Remember video 3? AI generates plausible text, not true text. Chain of thought just makes the plausible text generation process visible. The AI can hallucinate at step 1, then build step 2 on that hallucinated foundation, then build step 3 on the hallucinated steps 1 and 2. What you end up with is a very convincing, logical sounding chain of reasoning that's completely wrong. And it's actually more dangerous than a simple hallucination because it looks so thorough and well reasoned. Better reasoning structure does not equal truth. The AI is still completing patterns based on training data. If those patterns are wrong, or if it activates the wrong patterns at any step, showing the work doesn't magically fix it. You still need to verify claims. Chain of thought helps with logic structure, not with fact accuracy. So, how do you actually use this? The key is explicitly requesting steps. The exact words matter less than making it clear you want intermediate output, not just a final answer. Simplest version, solve this step by step, or show your work. That's usually enough. The model recognizes this pattern from its training data and knows to generate intermediate steps. You can be more explicit if you want. Think this through out loud, showing your reasoning at each step. That reinforces the instruction. Or you could provide structure. First, identify what we know. Second, determine what we need. Third, work through the solution. This gives the AI a framework to follow. The principle is the same across all variations. You're signaling that you want multiple outputs, not one jump to the answer. That changes how the model structures its pattern completion process. You've probably heard about OpenAI's O1 models being marketed as reasoning models with special capabilities. Let me tell you what's actually happening here. Automated chain of thought. These models do the chain of thought process internally behind the scenes before showing you the answer. You don't see all the intermediate steps, just the final result and maybe a summary. But the model is generating extensive step-by-step reasoning before it shows you anything. This is the same technique we're discussing, just baked into the model architecture instead of you manually requesting it. The mechanism is identical. Generate intermediate tokens, use them as context, generate more tokens, build scaffolding progressively. It's not reasoning in the sense of thinking or understanding. It's extended structured pattern completion. Still no consciousness, still no actual thought, just more steps happening where you can't see them. So don't be impressed by the marketing. It's chain of thought, automated. Useful? Sure. Revolutionary? Not really. It's the same principle we're covering today. Here's a practical way to think about whether to use this technique. Ask yourself, does this problem have distinct steps where each step builds on the previous one? If yes, if the answer depends on getting intermediate pieces right first, then chain of thought probably helps. Math, logic, planning, analysis, debugging, tasks where the path to the answer matters, not just the destination. If no, if it's one direct mapping from question to answer, then regular prompting is fine. Simple facts, quick translations, single step tasks. Adding chain of thought just wastes token and time. And there's a third category, tasks where showing work actually makes things worse. Creative writing is the obvious one. You want flow and spontaneity, not mechanical step by step construction. Some pattern completion works better when you let it run freely rather than forcing structure. The general principle, match the prompting technique to the task structure. If the task is inherently multi step, chain of thought helps. If it's not, don't force it. So let me tie all this together. Chain of thought works because each intermediate step generates tokens that become context for the next step. More context means better pattern matching. It's still just pattern completion from video 1, but structured to build information progressively rather than jumping straight to an answer. This is the most useful for complex multi-step problems where jumping straight to the answer is likely to activate the wrong patterns. Planning, analysis, logic, debugging, anything where the path matters, not just the destination. It's overkill for simple questions, single-step tasks, or situations where you just need speed. And it definitely doesn't prevent hallucinations or verify truth, just structures that reasoning processes more clearly. The key insight? You're not making the AI think. You're controlling how it builds context as it completes patterns. That's the actual mechanism, stripped of all the reasoning metaphors. And that's immediately actionable. You can use this today, right now, just by adding a few words to your prompts when working on complex problems. You now understand one of the most powerful prompting techniques available. And notice how it connects to everything we built so far. Video 1 taught you about pattern completion. Chain of thought is structured pattern completion. Video 3 taught you about hallucinations. Chain of thought doesn't prevent them. Video 5 covered prompting fundamentals. This is an advanced technique built on those basics. Everything connects. That's intentional. We're building a complete mental model of how AI actually works, piece by piece. And if this kind of education is useful for you, plain English explanations of what's really happening, no hype, no buzzwords, subscribe for more. We're going to keep building on this foundation. And if you want help applying these techniques to your actual business problems, visit eauclaireai.com. Let's figure out how to make AI genuinely useful for what you're trying to accomplish, not just theoretically interesting. Thanks for watching. We'll see you on the next one.